Hello students, we're going to continue on from where we left off. I didn't quite finish off section 1.2, but I will do that right now. There's a couple of slides here about coding. Let me tell you a little bit about coding. Sometimes when data is handed to you, some of the columns might be coded. An example here, this is some data where gender has been coded, and it says female 101111. So what you can say about that is the ones that are 0 are not females, and most likely they're males, and they have been coded that way. There's some reasons for doing that, but most of them are not very good reasons in our day and age, because you could just put male and female on there to code this data, and it would work just fine. Most modern software packages can handle males and females, but sometimes there's a good reason for coding 0 and 1 if you didn't want the data to be recognized or for some other reason. But so I would just say in most systems I don't worry about that, but StatCrunch has the ability to code data and to recode it and to put other names in there. I would just go with the standard male and female, because if you do a way like this, it sometimes is subject to errors. And it's just easier to record it in straight text form. So that's a good thing to keep in mind anyway as you look at this. Here's an example where we've got some stacked data. And by stacked, what we mean is that every row in this data set represents an observation, and each column represents a different variable. So we've got, in this case, they're measuring the birth weights, and they've got the weight of the baby that was born, whether or not the child was a female, and this is just a small subset, only 6 observations. I'm sure there's a bigger data set. And the third column is whether or not the mother had been smoking. Again, these could have been recorded as just text information rather than numeric, but the point there is that in stacked data, each row represents an observation, each column represents a variable. And that's the way that data often come to us. In fact, it's my favorite format. But another occasional way that you'll see data, shown on this next slide, is where you have, we call this unstacked data, where each column represents not only a variable, but also a group. So this one is men's heights on the left, women's heights on the right. So the data has been divided into 2 groups. Now, you could have had all of that data in one column, with a second column identifying whether it was a man or a woman. But sometimes when you just want to look at these as 2 separate groups, the data might be shown in this kind of a format. And so in this case, each row, the first row doesn't correspond to the same person. Obviously, it corresponds to a man's height and then a woman's height, and so they're not the same individuals. They're just a group of 3 individuals on the left and a group of 4 individuals on the right. We call that unstacked data. So that's really all you need to know about that. We're going to move on to section 1.3 and talk about organizing categorical data. Remember, categorical data is generally the non-numeric type of information that just classifies the data. And we want to organize the data simply because it makes it more interpretable. If you look at a big pile of data, if you will, with lots of information in it, it's really hard to pick out patterns and so on. So we're going to organize it to give us better information about what the data is telling us. So here's an example using what's called a two-way table. A two-way table probably means that there are 3 variables shown in the table. So here we're counting up the number of people that like football as their favorite sport to watch on TV, the number that like basketball, and then the number that like baseball, and then whether they are males or females, and then we've got the total numbers at the bottom. So you see that there were 52 that preferred football, 38 that preferred basketball, and 60 that preferred baseball, and then you see the males and females in each of those groups. It appears that females like baseball much more than males who tend to prefer football, and basketball is somewhere in the middle. You see the 3 variables on there. There's 2 categorical variables, the males and the females, and then there's 2, and that's one categorical variable. The other was which sport they preferred. And the third variable is just the count, the number that that made those preferences. And this data has been very well organized. You can imagine how the data would have come in raw form. It would have said, you know, male or female, football, basketball, or baseball, and you could have had 2 columns of data, and there would have been 60 rows of data. But this has now organized that data into a table that is fairly easy now to interpret. Okay, let's take a look at some Titanic data. There were 2,115 people aboard the Titanic when it hit an iceberg and sank in 1912. And they didn't have enough light bolts. I'm sure some of you have seen the movie Titanic or other depictions of what happened. And so the question here was, of the 2,100 people, how many survived? Well, 25% of them survived. How many people is that? Well, an easy way to figure that out, we've got 2,115, and we can multiply it by 0.253 or 25.3%. That would give us a number, okay, of the survivors. All right, so that that total would be 1,690. So 1,690 is 23%, 25.3% of the 2,115, and those are the. I think I did this wrong. That's the men and the women side of this. I'm sorry. So let's look at the other side of that, the 25.3%. I need to back up just a minute here. So the 25.3% is 535. That's the survivors. And we already had the men and women split out. That's how many were actually on the ship of the 2,115 people. Okay. So 535 survivors, which means we can, by subtraction, if we take the 535 from the 2,115, we have 1,579 that died from, obviously, from going down in the water. All right. Now, it does say something about of the men, only 20% survived. So we know there were 1,690 men. If we take 20% of 1,690, which would be, by the way, 169 multiplied by 2, that would be 338. We can put that in the table, right? So 338 men survived, and it would be easy to figure out how many died by taking 1,690 from the minus the 338. So there are 1,352 men that died. And now we can fill in the rest of this table, right? Because we know that the number that survived of the men plus the women has to add up to 535. So 535 minus the 138, that would give us the number of women who survived. I believe that would be 197. And similarly, we can use either one of these, either the row or the column, to get the number of women who died. Would be 425 minus the 127, which would be 228, I believe. No, 20. Guess what? That should be, we've got a discrepancy between the rows and the columns here. I'll have to correct that because the rows, you see the row adds up to 424 on the left, but it's, so that's what happens. We're off by 1 because of the percentages that are shown and maybe not enough decimals on the percentages. But you get the idea. If you have some of the information on here, and it does say there will be some rounding error right on the left, so right on the right hand side of my slide here. So that's a little bit about what happened. But you can see how that table was filled out. Another way of displaying this data is, besides two-way tables, is to use a Venn diagram, or a tree diagram is very commonly used. We're not going to cover tree diagrams in this particular course, but there's a Venn diagram of the total number of males and the total number who survived, and then there were 338. There were 338 plus 197 who survived, but 338 of those were males. So the 338 is the intersection of the males and the survivors. And that's how you show things in a Venn diagram. And we'll use Venn diagrams a little bit more when we get to our section on probability. So you see how those numbers are being used to get the display in the Venn diagram. Okay, and there's an example of the tree diagram, which splits out the 2,115 of those that survived and died, and then the survivors are split into men and women, and those that died are split into men and women as well on that tree diagram. So different ways of displaying the same information. Here's a table with similar kind of information. It's a table that shows the number of injuries from people that participated in various sports. So you see from baseball at the top all the way down to volleyball at the bottom, the number of injuries that were suffered by these participants. And if we ask the question at this point, what sport is the most dangerous? Well, these counts are shown here. So you could say, well, it looks like basketball is the most dangerous, but there's an important piece of information missing here, and that is, well, how many people play basketball? How many people go bowling and play football and so on? Isn't it interesting that there were 20,800 bowling injuries in whatever year that they're talking about here? But what I don't know from looking at this table is how many people actually participated. So that would be important information to ask as well. Yeah, how many players were there for all these different sports? So we can add a column here that has not only the number of injuries, but the number of participants. So you see the participant column is shown at the beginning. And when you look at that column, you can see that, wow, there were 45 million people that participated in bowling. So maybe 20,000 injuries isn't that bad, because that gives us a rate of injury. It says that you had 0.0046 basically, and you put that on a some kind of percentage basis. What they did is they chose to put it not on a percent basis, but on a rate per thousand. And so when you take the rate per thousand, which is basically that fourth column multiplied by 1,000, you see that the highest injury rate was in football, which isn't terribly surprising. And then the second highest is indeed basketball, followed by baseball and so on. The bowling injury rate, the lowest one here. My experience in bowling is I've done a lot of bowling and had a hard time getting injured doing it. But I have been injured playing basketball, and I never played football much and so on. But and I have suffered injuries playing softball as well. So these numbers look correct now that we've taken into account the number of participants. So if you're going to start comparing groups, you definitely want to, you definitely would like to have something that normalizes the data. By normal, I mean puts it on a per participant basis. And so that could be in terms of both counts and percentages are important here. This one shows an example that all the chickens were vaccinated for spotted fowl disease. 33% stayed healthy. 33% got sick, and the other one got away. Well, obviously, there's only 3 chickens here, but so that would have been nice to know at the beginning before we started quoting percentages. All right, I'm going to stop right there. That's the end of 1.3. It's a little bit shorter, but we'll move on to section 1.4. As I was saying, we'll move on to section 1.4 from here, which is the last section in chapter 1.